In this lesson, we're going to begin looking at terminating and repeating decimals. You already know that fractions can be written as decimals. Let's review that topic a little bit with this problem. Jenna figured out the cost of different fruits per piece and wrote the unit costs as fractions. Unit cost is a topic that we have discussed before in 6th grade. She wants to write each unit cost as a decimal to show the cost in cents. How can she write these common fractions as decimals? In the table, you can see the different fruits that she purchased and the unit cost per dollar. Strawberries 1/10, kiwi 1/5, apple 1/4, banana 1/2, and mango 3/4. What she wants to do is rewrite these as decimals so that she can talk about it in terms of money and how much cents each one would cost. So first, what we want to do is write each fraction as an equivalent fraction, which is another topic we have discussed before, with a denominator of either 10 or 100. Taking a look at the first one, 1/10. We can easily rewrite that one as 1/10. It already has a denominator of 10. And 1/10 is a common fraction that we know the decimal is 0.1. 1/10 as a decimal. 1/5 can also be written as a fraction with a denominator of 10 as 2/10. And when we think about how to write that, we know that 5 will go into 10 two times, and then 2 times 1 gives us that numerator of 2. And then we can write 2/10 as a decimal as 0.2, 2/10. 1/4 is going to be a fraction that's more easily written with the denominator of 100. So 1/4 as a fraction with the denominator of 100 is 25 over 100. And we want to use 100 as our denominator because 4 will go into 100 evenly. 4 doesn't go into 10 evenly. That's why we're not using 10 as our denominator. 4 goes into 100 25 times. 25 times 1 is 25. That's how we get our numerator of 25. And we can write 25 hundredths as a decimal as 0.25. 25 hundredths, because that second decimal place is our hundredths place. 1/2 we can write with a denominator of 10 because 2 will go into 10 evenly. 2 goes into 10 5 times, and 5 times 1 gives us a numerator of 5. And we can write that as a decimal as 0.5, 5/10. 3/4, we want to use 100 as our denominator because 4 will go into 100 evenly. 4 goes into 100 25 times. 25 times 3 is 75 for our numerator. And as a decimal, that is 75 hundredths, so 0.75. Looking at part B, what about the denominators of the fractions made it convenient to use equivalent fractions as a step in writing them as a decimal? So, as I discussed when we talked about whether we were using 100 or 10 as the denominator, we talked about that the denominators divided evenly. So, we wanted to look at whether the denominator of our unit fraction would go evenly into either 10 or 100, and that helped us determine what our denominator of our equivalent fraction should be. And then again, we used either 10 or 100 in our equivalent fraction so that we could easily write that as a decimal. Let's investigate a little bit more. In real life, fractions and decimals are used to represent weight, money, temperature, time, length, and distance. We often find data represented by fractions that would be easier to work with if they were decimals. This is why this topic is important. You know that 1/2 is 1 whole cut into 2 equal shares. So a half means 1 divided by 2. Remember that fraction bar is kind of like a division bar. And 1/4 means 1 divided by 4. You can use division to write any fraction as a decimal. So taking a look at some of our common fractions that we already know. So we really already know 1/2 as a decimal is 0.5. And 1/4 as a decimal is 0.25. And 3/4 are 0.75. So these are some common fractions with common decimal equivalents that we're used to. But we want to start looking at these examples so that we can apply this to more difficult fractions. So looking at the first one, 1/2 means 1 divided by 2. When the problem is set up, you see we have the denominator on the outside of our fraction bar and the numerator of 1 on the inside. But you've noticed we've done this before when we've talked about long division, 2 is not going to go into 1 evenly. So what we do is we add a decimal and a 0. And in my opinion, it's a good rule of thumb, when you add that decimal, go ahead and add 3 zeros. You don't always need all 3 zeros, but it's good to have just in case so that you remember what you need to do. So for this one, we know that 2 goes into 1 0 times. We bring up the decimal. 2 goes into 10 5 times. 5 times 2 is 10. Then we subtract and get 0. Once you get that 0 when you're subtracting, you know the problem is done. So we can stop. And we know that 1/2 as a decimal is 0.5. And then you can see in the other two examples, they're doing the same thing. You can verify that each decimal quotient is correct by multiplying the quotient by the divisor. So remember, multiplying and dividing are opposites of each other. That's why we can use that to check. The decimal number for each of these fractions has only 1 or 2 digits after the decimal point. But the decimals for some fractions have more digits, and some never end at all. Look at what happens when you divide to find the decimal for 1/3. So remember, when we're dividing that, the 3, the denominator, came on the outside, and the numerator on the inside. And you can see for this one, they've added a decimal with 3 zeros. Then doing the long division, you can see that there's a pattern emerging with this one. So every time they divide, they get 3. And then 3 times 3 is 9. Subtract with 1 left over, bring down a 0. Then goes in 3 times. 3 times 3 is 9. Subtract 1, bring down the 0. And that's going to continue on forever. So this brings us into our new topic of terminating and repeating decimals. So in the lesson that we're going to talk about next, you will learn about both terminating decimals. So an example of that is 0.25, which we've seen before, and repeating decimals. So like the example above, 0.33333, and it goes on forever. I want you to stop and highlight number 1 in the reflect, and we're going to come back to that in a few minutes. Let's look at writing fractions as decimals. How do the decimal forms of fractions help you compare their values? Find patterns or relationships among the fractions for 1/8, 2/8, 3/8, 4/8, and 5/8. So there's two different ways we can look at this. We can look at a picture and look at fraction bars or the fraction strip, or we can look at model it as a table. So let's focus on the picture first. So in the picture, you can see that each fraction strip is divided into 8 pieces. And then, depending on the fraction, depends on how many pieces are shaded. So for the first fraction, 1/8, there's 1 piece shaded. 2/8, there's 2 pieces, and so on. So you can see, as the numerator gets bigger, your fraction bar has more pieces shaded. Now, when we take that a step further and we look at it as a table, we're going to look at that fraction and how it's written as a decimal. So 1/8 as a decimal is 0.125. Now, the way that we get that is over here on the side where they've done the long division, 8 into 1. And they've added the decimal with 3 zeros. 8 goes into 1 0 times, so they bring their decimal point up. And then 8 goes into 2 1 time. 1 times 8 is 8. They subtract. 10 minus 8 is 2. Bring down your 0. And so on. And they continue until they get 0 as a denominator. Or I'm sorry, they get 0 as when they subtract. Then you have 2/8 as a decimal. Doing that long division is 0.250, and so on. Then we have 6/8 and 7/8. So we want to divide 8 into 6. So we put our decimal with 3 zeros. I'm going to go ahead and bring up my decimal. We just bring it straight up. So 8 goes into 6 0 times. 8 goes into 60 7 times. 7 times 8 is 56. Subtract. We get 4. Bring down a 0. 8 goes into 40 5 times. 5 times 8 is 40. Subtract and we get 0. And once we get that 0 there, we can stop. So 6/8 as a decimal is 0.75. And we'll do the same thing for 7/8. 8 into 7. I'm going to go ahead and add my decimal with 3 zeros. Bringing my decimal up. I know 8 won't go into 7, but I know 8 will go into 70 8 times. And 8 times 8 is 64. 70 minus 64 is 6. Bring down a 0. I know 8 will go into 60 7 times. 7 times 8 is 56. Subtract and get 4. Bring down a 0. 8 will go into 45 times. 5 times 8 is 40. Subtract and get 0. And again, now that I have 0 from my subtraction, I can stop. I'm done. So 7/8 as a decimal is 0.875. So look for a pattern and think about how to find the decimal forms of 6/8 and 7/8. Let's look at it together and see if we can make a connection. Describe the pattern in the decimal numbers in the table in the model it and tell how the numbers change and why. So taking a look at that fraction to decimal and taking a look at what that numerator is compared to the decimal, and then take a look at each of the decimals and see if you can notice a pattern. I'll give you a minute to think about it. So if you notice on the fractions, your fractions are going, the numerator is going up by 1 each time. 1/8, 2/8, 3/8, and so on. Well, if you look at your decimal values and how those go up, each decimal goes up by 0.125 each time. So each decimal increases by 0.125. So it increases by an eighth each time because the fraction increases by an eighth. So when you extend that pattern like we did for the 6/8 and 7/8, so for the 6/8, when we extended that pattern, we got 0.75. So for the 6/8, that was equal to 0.75. Well, if you notice, for the 5/8, that was 0.625. So if we're saying that it increases by 0.125 each time, we could take that 5/8 value, the decimal value of it, add 0.125, and you get 0.75. Well, if we add 0.125 to our 6/8 value, then our 7/8 value is that 0.875. So it's another way of looking at how you can determine that fraction to decimal. So doing that long division, or you can figure out that pattern and see how much it's going up each time. And as long as your fraction is going up by the same amount each time, your decimal is going to do the same. So when we look at this chart below, we want to write the decimal forms of the fraction 1/8, 1/4, and 1/2. So like we saw on the previous page, we know that 1/8 is 0.125. When I think about 1/4, I like to think about in terms of quarters, because you're dividing a whole into 4 pieces. And when you think of a dollar, you divide a dollar into 4 quarters. Well, 1/4, 1/4 is 25 cents. And when that's written, that's 0.25. And you can think of the half kind of in the same way. When you have half of a dollar, you have 2 quarters, you have 50 cents, which is 0.5 or 0.50, depending on how many zeros you want to add on to the end. So next I want you to explain how you could get from one row to the next by multiplying. So taking a look at the chart in number 4, and I'm going to give you a minute just to think, how could you go from one row to the next by multiplying? So looking at those fractions and how they compare, and look at those decimals and see what you notice. I'll give you a minute to think about that. So what you may have noticed is when you're looking at the fraction, if we start from the bottom and go up, 2, looking at your denominator, 2 times 2 is 4. 4 times 2 is 8. So going from the bottom up, it's doubling. So when we're talking about fractions, it's a little bit different. We want to think a little bit backwards. So 1/8 doubled is 1/4. 1/4 doubled is 1/2. So when we look at our decimal, we can see that same pattern. 0.125 doubled times 2 is 0.25. And 0.25 times 2 is 0.5. So to get for this table, to get from one row to the next, you can double or multiply by 2 to get to your next value. And that's true because the fraction forms each time double. So whatever pattern you can apply to your fraction forms, you can also apply that same pattern to the decimal forms. Taking a look at number 6, explain how you could build on knowing the decimal form of 1/5, which you found in the reflect, to find the decimal form of 3/5, and then write it as the decimal. I'm going to give you a minute to think about that. So the decimal form of 1/5, remember, was 0.2. So if we're going from 1/5 to 3/5, that's 3 times. So we can say 0.2 times 3, which is going to give us 0.6, which would be the fraction form or the decimal form of 3/5. So I jumped, instead of going from 1/5, 2/5, 3/5 and adding 0.2, I jumped to that 3/5 by multiplying it by 3, because that's how many jumps I was going to make. Go ahead and highlight the number 7 and 8 on the try it.